Welcome to Math 2318, Section 1.4. Before we get started in this section, we need to talk about matrix multiplication. When it's possible to perform the multiplication, and if it is possible, how do you do it? So if I want to multiply two matrices together, the first thing I need to check is the size. So for example, if A is 2 by 3 and B is 2 by 1, the multiplication is not possible. It's only possible when the number of columns of A matches the number of rows of B. So here I have 3 for the columns of A, 2 for the rows of B, and that's not possible. So what about if I had A times B and A was 2 by 3 and B happened to be 3 by 4? Well, notice the columns and the rows match up. So the multiplication is possible. So next, what's the size of the answer going to be? And the size of the answer is going to be the outside number here, meaning the product size would be 2 by 4. Alright, so now we know when the multiplication is defined. Alright, so how do we find the numbers in the product? So let's say A times B is defined and I get a product C. So the elements in this matrix I can write as Cij. So I and J, what do these numbers mean? They're the row position and column position. It turns out that to get the answers, how do I get Cij? Well, I take the ith row of A and I multiply it by the jth column of B. So as an example here, I have two matrices, both are 2 by 2, and so the answer is going to be 2 by 2. The answers will be C11, C12, C21, and C22. So to get C11, I take the first row of A, so here's row 1 of A, so think of this as A multiplied by B is C. So I've got the first row of A times the first column of B. So I simply take 1 times 2 is 2, 2 times 5 is 10, 2 plus 10 is 12. C12, first row of A, I get the second column of B. 1 times 4 is 4, 2 times 6 is 12, and we add them up and we get 16. What about C22? Let's see, C22 would be the second row of A, 3, 4, times the second column of B, which is 4, 6. So 3 times 4 is 12, 4 times 6 is 24, and the sum is 36. So now we know when the multiplication is defined and how we actually perform the multiplication. Alright, so in question 1 here, I have a matrix. This first matrix has 3 rows, 2 columns, so 3 by 2. The second matrix has 3 rows and 1 column, and notice that the number of columns of A does not match the number of rows of B. So the multiplication is not defined. Alright, in question 2, let's see, I've got 3 rows, 2 columns, 2 rows, 1 column. So the number of columns of A is 2, number of rows of B is 2, so that's the multiplication is defined. So my answer is going to be 3 by 1. All right, so the answer will have that particular size. So let's come down here and figure out how we would do it. So if my answer of A times B is C, my C, remember, was looking like the following. C11, C12, C21, C31. All right, so how do we get them? C11, first row, first column. C21, second row, first column. So minus 2 times 5 is a minus 10 plus 6, and I get a minus 4. 3, 1, third row, first column to get 29. All right, so in problem 3 here, we have matrix A. We would like to get matrix B, so I'm trying to solve, is it possible to find an X where A multiplied by that X would give me B? Well, let's see, what's the size of X have to be? If this is 3 by 3 and I get a 3 by 1, then my vector X needs to also be 3 by 1. So I formed the augmented matrix here. I did row reduction to get my ones and zeros. And so I found, yes, it is possible to find an X, this X, minus 733, where A multiplied by this X results in the vector B. And you should actually do the multiplication to verify it actually does that. All right, in question 4 here, we have U and we have matrix A. So the question is it possible that I can find C1, C2, and C3, three constants, where if I take those constants and multiply them by the columns of A, I can get vector U. So this would say that U is a subset of R3 that is actually spanned by those columns of A. So we have to solve the system to see if it's possible or not. So I form the augmented matrix. I do row reduction to find out what do I get, and what I see is I get this row of 0, 0, 0, 1, which means there's no solution. So what that means is vector U is not in the subspace spanned by the columns of matrix A. And in the last question here, I've got V1, V2, V3. And so the question is, do these three vectors span R4? So would it be possible to find C1 V1 plus C2 V2 plus C3 V3, and I'd like it to be able to give me all possible U in R4. Is that possible? Well, let's see, the vectors look right. 1, 2, 3, 4. So there are 4 elements there. That is a member of R4. The problem is I only have 3 vectors. And it turns out that to be able to span the space, I have to have as many vectors as the dimension of the space. So if you think about it from your encounters with the vectors in R3, I, J, and K from physics, those span R3. Later in the course, we'll see other sets of vectors that would span R3. But again, that's our common vectors I, which was 1, 0, 0, J, which is 0, 1, 0, and K, which is 0, 0, 1. And what we see, if you remember, we can use those to write any vector in R3. So a little bit added from the homework question. So this would give me all U's in R3.